We ask a simple question: with recent advances in object pose and shape estimation, can modular methods outperform end-to-end grasping from a single RGB-D view? As in many real-world scenarios, objects are located inside storage compartments such as cabinets or shelves, where the robot cannot observe them from multiple viewpoints before grasping. Therefore, a grasp synthesis method must be just as accurate and reliable when operating from a partial or single view as when multiple views are available. End-to-end grasping methods currently dominate single-view RGB-D grasping, in part because pose and shape estimation from a single view has historically been challenging and unreliable for grasp planning. However, recent encoder-decoder and diffusion-based models now produce strong, category-agnostic reconstructions from just one RGB-D observation. This progress motivated us to revisit whether pose and shape estimation can once again benefit grasp synthesis. The figure illustrates the advantage of single-view shape completion leading to a large sample of collision-free and stable grasps, shown in green, when compared to end-to-end methods. We compare a state-of-the-art end-to-end baseline, any grasp, against 3 modular grasping pipelines. The modular methods first estimate object shape and pose using either encoder-decoder models such as SAM3D and CRISP or diffusion-based models such as SceneComplete, and then sample antipodal grasps on the reconstruction. We do extensive evaluations in simulated environments, real-world datasets, and grasping experiments. We evaluate grasp quality using grasp collision rate, force closure failure rate, and grasp success rate. Across all 3 benchmarks, we consistently observe that modular grasping pipelines outperform the end-to-end baseline, with significantly lower force closure failures and higher grasp success. We also find that the reconstructions enable the modular methods to generate a larger number of physically valid grasps per object, improving robustness under partial observations. To further validate our approach, we perform real-world grasping experiments using an XARM7 manipulator. The modular method consistently produces successful and stable grasps across all tested objects, whereas any grasp often produces unstable grasps due to asymmetric contacts. We now demonstrate that single-view pose and shape estimation can also be used for language-conditioned grasping. Our modular pipeline reconstructs the shapes and poses of all objects from a single RGB-D observation. This digital twin is then fed into LERF-TOGO to localize grasps based on language queries. The modular approach that reconstructs the objects from a single view achieves qualitatively comparable performance to the LERF-TOGO baseline that uses multiple views as input. These results indicate that we are now at an inflection point. Recent advances in object pose and shape estimation and single-view reconstruction have begun to provide tangible advantages for downstream tasks such as grasping. Our results show that modular methods, that estimate object pose and shape followed by antipodal grasp sampling, achieve superior performance than the end-to-end method, in collision avoidance, force closure, and grasp stability. The performance of the modular method, and the extent of the gain, remain sensitive to reconstruction errors in cluttered scenes and are constrained by the runtime of both pose and shape estimation and antipodal grasp sampling.